Okay, YouTubers, we got part two of the Magloop. Uh, we had an epic fail with the 5 foot. Remember my warning about the clamps? Uh-huh. Yeah. Found it on the floor all dented up. So we had to reevaluate. We got this super huge thud of a capacitor in this air capacitor, which we're going to talk about today too. We're going to show you this, and we're going to show you some signals with the new loop. We're going to show you the loop here, but I'm going to talk to you a little bit about how these work. Most people don't know. I had to go back quite a ways and watch a few seminars on YouTube. And these were like old. One of them went back to like 2008, and because I just couldn't find the information I was looking for, and I finally found out watching a few seminars about mag loops and how they work. Because I was kind of confused, and I found out something by testing out the 5 foot loop. They work off the magnetic field and not the electric field. And there's two different things there. If you got a vertical antenna, metal antenna, it works mainly off the electric field. And that's how you're getting a lot of noise. My long wire, I was getting a little bit of noise, extra noise from someplace. And so when I switched to the magnetic loop, it totally went away. I was confused about that, and I wanted to know how that was. And apparently, the magnetic loop works off this other field, and it's horizontal. Some people say this switches back and forth, the electric and the magnetic, but I've seen these diagrams online showing the magnetic field being vertical, and I believe that's wrong from what I've been told. Now, it may flip and back and forth, I'm not for sure. It's really confusing on some of the information I'm getting. But from the way I take it, this magnetic field works a hell of a lot different than this electric field for picking up noise. And there's just no noise, hardly any noise on the magnetic field compared to the electric field. So what happened, I was testing the 5 foot one, and the coupler broke, let loose, and I was pretty upset. Had to take a day off from that one and regroup, but we made a new build. I dropped the size down because you're going to see this big thud of a capacitor I got. It is awesome. I'm going to show you the loop, but I wanted to show you some of these capacitors. And here's a thing. You don't need to spend your money on these vacuum capacitors, okay? These are for transmit. If you're going to transmit, these are what you want, because you can transmit a ton of power through them. These do not work really well for receive type, which is what we're doing, and because we want to get our SDR receiving good, and we just accomplished that, and I'm going to show you. But you don't want to buy one of these for your receive. It's a waste of money. You're really what you want to get. I found these on Amazon. And now these are not good for transmitting power. You're maybe getting about 5 watts, 10 watts before that thing will arc over, and you're going to have a bad day. There's a few reasons why for receive we don't want to use these variables, vacuums. And one is, if you go too far on the adjustment on these, you kill it. You just wasted like $200. So you got to be really careful about your adjustment knob, how far you can go with it up and down. Um, Plus, they require a choke on the output to balance them. Um, you don't need to run a choke with a veritable air supply. The actual air capacitor will balance the antenna for you. And these, some people I've noticed have trouble, and they'll also fade your signal. These here, they'll attenuate the signal a little bit and make it offset. Now, if you're running big power or you want to transmit, a couple hundred watts out of Maglev, this is what you want right here. You don't want to mess with one of these. The one of these will kill it. But yeah, I just wanted to let you guys know, if you're trying to build something cheap, like I'm going to show you, for what I got in this Maglev and what you're going to see on the SDR, you're going to be amazed. I was shocked. But yeah, if you're going to build a transmit one, this is what you want. But if you're going receive, no. Okay, we're going to set those aside. Now, I found these, and this is what you want. Okay, and I'm going to explain these picofards. These are the puff everybody's talking about, right? Your puff is really a picofarad. I think that's how you spell it anyway. But that's your puff rating. Now, it works opposite. If you get one that's low, I'll give you the example of the one I got. My one I got's a 64,975, okay? This 975 number doesn't get you up in frequency. It gets you down in frequency. And the lower you go, that's the higher the number here, okay? This number here will take you higher in your frequency, okay? You get up, into your 100, 10 meters, 6 meters, stuff like that. That's where this number is going to start working its way in. But I've got this big 975. Now, you can buy them in this small size. I've seen them. They're in a fairly smaller package than the one I'm going to show you. But this one here, I've seen them up to 1,000 picofarads. Okay, so that's your puff rating. Everybody calls it puff. The more puff you got, the longer your strain is there, and I'll show you how this works on the puff rating here in a little while. So we'll set this aside, but you can get these cheap on Amazon. I've seen one for $35 on Amazon, but they sold out. eBay's got them, okay. And they're smaller. They come from Thailand. So it's going to take a little while if you get it. If you find one in America, I found an American guy. What was his name? Good Stuff, I think, 04 or something other. And that's where I got my capacitor from. And he was in New York, and I got it in like 3 days. Excellent packaging. I mean, it was wrapped great. But you can get these smaller ones, and they'll work just fine for a receive. So you can throw in 25 to 40 bucks, get you a 1,000, or I've seen them like 9 something to 1,000, something like that range. As long as you get a high number, you're going to go lower in your frequency, and that's usually where 80 meter 160 sits, somewhere in there. Mine works all the way up to mine works all the way up into right at about 21 megahertz, all the way down to long wave. I can even get singles to bump on long wave with it, but you're going to see. I'll show you but this is how you're going to find out. If you're building a mag loop, you need to know the ratios for your loops, okay? And this is what the ratio is. It's 1 to 5. So you got your outer diameter of your loop right there, okay? You need to know what the size of that little one needs to be, right? This is a really easy math problem to figure out. You measure your diameter, okay? Punch that in. Say it's 3 feet, okay? So we're going to go 36 inches, okay? And then you're going to times that by 2, okay? That'll give you your 1 to 5 ratio. and then we're going to times that number by pi, 3.14. And then that will give you your length, all right? Your length of your smaller loop, of this smaller loop right there. And that's how you do it. Get your big loop made, measure it out. Hey, that's what I got. Punch this little math problem in there to your calculator, and boom, now you know the length of your top loop here, so you can couple it to your antenna. And I wanted to tell you that because it took me a while to find that on YouTube, and like a half a day of going through stuff, and finally found it. Kevin Laughlin, the old tech guy, got to give him another hit there, because he did good on that. These measurements work great. All right, so let's get to looking at the antenna. Now that you know what to get, this is what you want to get. You want to get it in a high puff, okay? And then the reason why you have less noise is because these magloops work off the magnetic field, not the electric field, okay? That's the difference between them. And there is a difference too. I've found out with the 5-foot loop I was testing. I found out a little something, but we'll get to that later on another one. But anyway, let's get you over here and let's see this loop. So look at that big thud of a capacitor. This thing is huge. I mean, that's my hand right there. It is absolutely huge. That thing is 64 to 975 on the picofarads. But here's the loop. I had to drop the size down to a 3-foot loop. Okay? And the reason why, it was too heavy and it was hard to tune at the 5-foot. So I made it over into 3 feet, and what I did, I doubled up the loops. This is one single loop, right? But I doubled it. And down here is where I made the solder connection. Right there. And it just is soldered up right there. Okay. Joined together. I kind of bent this one into that one. And what this does is, by going through, drilling through this, it gives you a hell of a lot more support for this loop side to side. This one's actually really pretty sturdy now. These are now 1.5 inches, I believe. Gap difference between here and here. And I just staggered them along, as you can see there. And then we come up here, you can see my hellacious glue job. Don't do this if you're going to put it outside. That glue will come right off in the cold. So I'm going to change this. I'm just testing it right now. But this is the smaller loop right there. Give you a better shot. And then this is the coax coming in. It just goes the, let me show you here. So we got our coax. We take one to one side and one to the other side there. To give you an idea what's inside there. I just put it in a little box, of Hunter specialty box here, just to weatherproof it. And bring the coax down. Now you can see how I hung the capacitor off of it. That damn thing is heavy, but man, it works great. Now you see this little orange thing here. Okay, this is a safety, because this is not glued into this. And I went to move it and it almost fell out of there. And I realized, man, I need a safety for this. So I drilled a hole, and this just kind of pulls out there. So, but yeah, that capacitor is a stud. Now, if you look down here, what I did, I siliconed it. Now, I'll show you a trick. If you need to mount something flat to a PVC pipe, what you do is you leave your excess that you want to put up into your mounting area, and then just cut that pipe in half. I just cut that pipe in half all the way down, and then I put a nice little plastic mounting box on there and siliconed it to it. Works great. And we're getting ready for our stepper motor. Now luckily, whenever the guy I bought this off of, he included these porcelain insulators. So I went ahead and worked in a shaft on that, and now we got a shaft for a stepper motor. And down below, we're going to come out here with an elbow and make a mounting area for our stepper motor right here and link that in. But that's later. And I'm going to point out this to you. Just so you don't break your coupler like this, so that won't happen to you. This is 1.5 inches. This pipe is 1.25 inches. This is 1.5 inches, and I bought reducer rings to go inside the 1.5 inches. So effectively, I'm doubling the pipe at the connection point with this. Okay, it gives me a hell of a lot more strength than them other ones. These are the inserts to condense it down to 1.25 inches. Okay, and of course you have to buy that and these, but I went ahead and bought them when I bought this so that I could mount the there's a piece of PVC in here real short, so I could get that tucked tight, because you want these wires run as short as possible. And all it does is it goes, you can see the gap there, it just goes one through the PVC, one wire connects from the plate to this one, and then the other wire connects to the veritable to this side right there. Really sturdy, it's pretty strong. You can maneuver it around, and I'm going to eventually silicone it and put it outside. I'm going to get a box for this and a box for the stepper motor. That's going to be on its way. But yeah, it's a really good design too, this doubling up. I first made it initially with one wire. I had one wire. Let's see. Yeah, I had the first wire here, and it did okay, but I thought it could be better, so I doubled the wire. And then when I brought it down here, you just joined it in, connected it there, and this actually gave me about 10 more dB on the gain for the signal, so it really worked. So there you have it. Let me show you the back side here. There you go. You can see how close that coupling loop is. Now I had Dremel these right here because I wanted that to get that super close but not touch. So I Dremeled those, and I've got it like millimeters. I mean, it's small right there, but it couples great. Pull that back. But yeah, I'm gonna fix this, put a cap on it, and then paint it. I'm gonna silicone this, get this hot glue off. This is just temporary so I can test with it. And then there's the compact tenor. Now this is getting right. This is the next project. I'm gonna install it here and come up and get it into the magnetic coupling. I'm gonna couple it here, and I shouldn't have to move this for just receiving. So I'm hoping that will work. But that'll be next. Well, let me get you set up and we'll start the SDR. Here, I'm gonna step out of the way. And I'm gonna get get you some signals going here because you need to see what this thing can do. You're going to be amazed. I was. So, I've turned the bias T driver on. Oh, I'm not in that shot. I've turned that bias T driver on, and now we've got our LNA working. Okay. Now let's get sharp up. Make sure your shot is good. Okay. All right. Let's get some signals. Okay, I'm going to mute it because I want you to see something. I'm going to roll this capacitor, and I want you to watch the screen as that capacitor, as this signal right through here, I'll start pulling almost 30 dB of signal. That's amazing. But let me grab the knob here and we'll turn it. And you can see it just run itself down the look at the signals pop up. You can even see it on the scope, me moving it across the scope. And I can do that across the whole band all the way up to like 17 to 20 megahertz. And it'll start to get flat, but it's amazing. And I want to show you, you see here, there's hardly nothing. You can see one maybe popping through right there. I want to zoom in. And I'll roll this capacitor back. And you'll watch the, there it comes, riding the wave. It is awesome. Now, if you watch the noise level, you can see a noise stream right here. And that is just pure dB. It is awesome. Let me cut it off so you can hear some of these signals. I'll grab one here. There's one.
Average person, no. Honest to God, no.
You can see the noise over here. If I move the capacitor, you'll see why this mag loop is so nice. I can move this noise right into this or away from it. If you watch the scope, you'll see where the noise pattern is moving. And if I pull it out, you can really see it's right here. Turning the capacitor. There it is. Now you can see our noise pattern right over here now. And the range of that magnetic loop is amazing. You would think it's a 20 megahertz or 20 kilohertz range, but if I move this noise level over here, I'm still picking up right here. You can see the noise, but I'm still picking up the signal. This one is just barely squeaking in over here, so you look at that range on the scope, that's a huge range that this antenna is actually bringing in. And has a strong signals. I was amazed at, I love to watch this far back, and you can just see the wave run down the screen, left, right, and just watch the signals pop up. Look at this one just topping out. That's amazing. And you can see it on the scope. It for a 3-foot magnetic loop that's inside, that's really good signals. Let's move up the band. You can see some noise level here. I'm picking that up from my neighbor. We'll pull back here and show you 30 meter. I'll bump the capacitor again. Whoop, there it is. Click on a signal. Whoa, there it is. Look at that dB. Look at that. This thing is amazing. The wire antenna does not do as well as this, and this is absolutely amazing. I'm really happy with it. But I wanted to, oops, sorry about that. I wanted you to be able to see that you can move this noise out of your way. Push this noise over here and still receive the signal. That, to see that on the scope, that is a really good antenna. To see that go across that scope. And I built that antenna for, the capacitor was $73. Let me pause this. But I love the way this tunes. I can't wait to get the stepper motor on it. But I wanted to show you some signals. I do listen to my comments, and hope you subscribe. You can see how this is constructed. If you got to know a little bit about soldering, I had to use a torch on getting these joints together here. So you do need to know a little bit about soldering. But if you bought a capacitor, you could buy one smaller than this. It would still work. You may not get near the peak on your screen. You know, you won't get this kind of peak. That's gosh, you know, that's going from 55 all the way up to 30. That's 25 dB, 30 dB a gain. It's just amazing. But yeah, if you go with a smaller capacitor, you may not get that kind of gain, but you'll still get really good gain. The amount of wire I got in this is 3 feet diameter. I think I paid $1.35 a foot for this, and the capacitor was the most expensive part of it right here. But this is the other long wire antenna. It does good, but nowhere near what that Maglev does. I've seen an MFJ, the one that's $500, and you won't do nothing like like what this is doing for that amount of money. So, but yeah, I wanted y'all to see that, and I hope well, I hope to get the other wideband. This thing receive range is 100 megahertz all the way to 2 gigahertz. So I hope to get that hooked up next, and hopefully show you some videos on it coupled to this loop right here. And